Hello students, in this lecture we're going to talk about excitation-contraction coupling. And this is where we couple, we integrate, we link the electrical impulse from the neuron coming down to the muscle fiber and ultimately causing contraction. Hence the term excitation-contraction coupling. How do we how does that electrical impulse from the neuron cause contraction in the muscle? It will start Again, it will start with an action potential at the neuromuscular junction. And notice that it requires two components. It requires calcium. Calcium is the regulatory ion that will allow for contraction. And ATP is the energy source that gives us contraction. And ultimately, what this will cause, when we have this contraction, when we have the myosin and actin, when we have the thickening of the filaments interacting, that will cause the sarcomeres to shorten, which ultimately leads to the whole muscle shortening. Notice a couple of key things. The action potential, that electrical impulse, is going to be propagated. It's going to move along the sarcolemma, the membrane of the muscle cell, down the T-tubules. As it moves down the T-tubules, it will stimulate the release of calcium from the sarcoplasmic reticulum. And then calcium will interact with the regulatory proteins troponin and tropomyosin on the thin filaments to ultimately cause contraction. So here we start. Here, this should look familiar to you. This is the neuromuscular junction. And here is the acetylcholine has been released. And the acetylcholine, the neurotransmitter, has bound to the acetylcholine receptor on the muscle fiber and has created a new action potential. And here's this new action potential represented by this red arrow. The action potential travels along the membrane of the muscle fiber. It encounters a T-tubule. And at the point where the action potential encounters a T-tubule, that action potential, that electrical impulse, then begins to move down the T-tubule. Let's take a closer look and pick it up from that step. Here is that red arrow again. Here's the action potential moving along the membrane of the muscle fiber. Now the action potential is then traveling down the T-tubule. As the action potential travels down the T-tubule, it stimulates voltage-gated, voltage-regulated calcium channels in the sarcoplasmic reticulum that opens these, the short name for that is calcium gates. The action potential stimulates the opening of calcium gates, and calcium is released out of the sarcoplasmic reticulum into the cell and to and around the myofibrils of the muscle cell. Now, what does that calcium do? That calcium then goes and it binds to troponin. And when calcium binds to troponin, it moves tropomyosin. It exposes the active binding sites for myosin that are on actin. And myosin then binds to the actin, forms a cross bridge, and pulls, and you get contraction. Again, let's take a closer look at these events. So here is the electrical impulse. Here's the action potential. The action potential travels down the T-tubule. And as the action potential travels down the T-tubule, it opens calcium gates in the sarcoplasmic reticulum. And calcium moves out of the sarcoplasmic reticulum and into the muscle cell, where it can then act with the myofibrils and interact with the regulatory proteins troponin and tropomyosin. The calcium is represented by these little red dots. Now, once calcium is released from the sarcoplasmic reticulum, calcium will bind to troponin. And when here's calcium bound to troponin. When calcium binds to troponin, it moves tropomyosin, and that exposes the active binding sites on actin. And when those active binding sites are exposed, myosin can bind to actin, and using ATP as an energy source, myosin can pull on actin to cause contraction. So again, the role of calcium. When calcium is low, when there's no calcium out in the cell, the muscle fiber cell, the tropomyosin is blocking the active sites on actin. Myosin heads cannot attach to actin, and the muscle fiber is relaxed. However, when we have an electrical impulse that travels down the tubules. It causes calcium to be released from the sarcoplasmic reticulum. That calcium then will bind to troponin. The calcium binds to troponin. It causes tropomyosin to move, exposing the active sites on actin. Myosin can then bind to actin, creating cross bridges and pull on the actin and causing contraction. And then when the stimulation is stopped and we're looking for relaxation, the calcium is pumped back into the sarcoplasmic reticulum. And when we remove the calcium, troponin moves. It causes tropomyosin to move. The active sites and actin are once again covered up, and the muscle is relaxed. Thank you.